Hi, my name is Claire Shope, and I'm a naturalist with ACES. Before we get started, I want to give everyone who came a big thank you for braving the snow and being out here for our very first Naturalist Night of the season at ACES. So Naturalist Night is a joint presentation of Wilderness Workshop, the Aspen Center for Environmental Studies, and Roaring Fork Audubon. And we encourage you, after this presentation, to go out and check out some of the literature and the displays on the tables and counters outside. These talks are hosted each week through mid-March at ACES at 7 p.m. on Thursdays and at 5:30 p.m. at Carbondale on Wednesdays. I want to give a big thank you to the sponsors that we have tonight. Without them, we wouldn't be able to film these presentations and allow the general public in. So thank you to our tonight's featured sponsor, Village Smithy and Bonfire Coffee. And also a big thank you to Two Leaves and a Bud Tea Company. The tea you're drinking right now is from them. And GrassRoots TV will air a presentation of this talk on Channel 12 Up Valley and Channel 82 Down Valley. And these videos will also be available on our organization's websites. Next week's presentation, just to give a small plug, is going to be a really exciting one. It's with Stephanie Lukowski, and she's going to be talking about mammoths and mastodons. So I want to give a big thank you to April Long, who's our speaker tonight, and just give a little introduction before she starts. April Long is the Stormwater Manager and Clean River Initiative Program Manager for the City of Aspen, and she focuses on water quality and river health improvements for the Roaring Fork River in Aspen. April graduated from Auburn University with a biosystems engineering degree, and she's a steering committee member of the Roaring Fork Watershed Collaborative, so she works closely with other mountain resort communities to solve stormwater management and river health issues that are unique to mountain towns. So thank you guys again for coming out, and here is April Long.
Thanks, Claire. Let's take that with you. All right, give me just a second, guys, to get my presentation pulled up here. All right. Thank you so much for having me here tonight, and Happy New Year to all of you. It's an honor and a privilege to be asked to speak at Naturalist Nights. This is, years of collaboration between ACES and Wilderness Workshop, and I'm very flattered to be asked to be one of the speakers on one of these fascinating topics that you're going to hear this year. So let me start by saying that when I graduated from high school, I wanted to be an astronaut. Now, I went to a school that had graduated many famous astronauts, and I was going to major in aerospace engineering and graduate and go into the Navy and become a pilot, and then work for NASA. And it was about my second year in college where I took a class called thermodynamics. Have any of you ever taken thermodynamics? Good. So then you'll know that it is one of the worst classes in the world. I hated it. I hated the teacher, and therefore I hated everything about engineering and was ready to drop out. Luckily, I had a very wise and kind advisor who knew that this class might be the end of me, might be the death of me. And so he suggested that I take all of my fun classes at the same time that I take thermodynamics to give me some relief. And so fun for an engineering student is not tennis. We don't get to take fun electives like that, but I did get to take a class in microbiology taught by a professor from the CDC. And it was in that class that I learned that you could remove oil by introducing bacteria. You could remove water pollution by introducing something natural like bacteria. These bacteria would then eat the oil, and after they ran out of food, they would simply die and go away. And so there would be no introduction of any kind of chemical or anything man-made. It was simply a natural solution to a really big water pollution problem. And so I asked my advisor if engineers really did this. Would this be something I could really do with an engineering degree? And he assured me that I could, and so it was also around this time that I learned that there's only probably realized that there's only about 5 astronauts in the world. And I'm not that competitive of a person, really didn't want to be an astronaut that badly. And so luckily I changed my major to biosystems engineering and graduated, and about 2 months into my job in my cubicle in Nashville, I had done my 4th floodplain model of the week and thought my advisor might have lied to me. And so 15 years later, I'm here, I'm doing what I love, which is solving some of our environmental problems, some of the worst environmental problems that we could have with the most natural systems that we can. And so thankfully, my advisor advised me well. So in my experience as an engineer, I have discovered that there's basically 2 ways that you can solve a problem. You can control the environment or you can mimic the environment. And mimicking the environment is a much easier and more sustainable solution to engineering designs. And so that's what we're here to talk about tonight. In what ways are we in the Roaring Fork Valley using nature as guidance and as design inspiration? This idea of using nature as a design inspiration has a name. It's called biomimicry. And this is a great definition that I pulled from the Institute for Biomimicry, which is a great resource if you like this presentation and are interested in learning more about biomimicry. So this says that biomimicry is an approach to innovation that seeks sustainable solutions to human challenges by emulating nature's time-tested patterns and trait. Another way to think about it is, we're trying to mimic the environment, use the environment as a design guidance. We're not trying to exploit our environmental resources. The founder of the Biomimicry Institute, Janine Benyus, also says this: we're surrounded by genius. And she goes on to say that, whatever problem it is out there, we're not the first ones to solve it. There are organisms that have lived here for 3.8 billion years, and those organisms have been through every problem that we could think of as humans. And we should be looking to how they have solved problems. Rather than controlling our environment, like I was talking about earlier, we should be looking to mimic that environment. And, controlling can only get you so far in design guidance and as a species. And so if we think about, these organisms that have been here for 3.8 billion years, they've done so gracefully and so seamlessly, and we as a species should begin thinking about how we can do that as well. These are some great examples of what I'm talking about as using nature as inspiration. This is Velcro. This is something we use in our everyday life. And so there was a guy that was hiking in the 1940s, and he wondered why these little kookaburras, or hitchhikers as we call them in the South, are able to attach to clothing so well. And able to attach to his dog, I think is exactly what he was wondering after removing 50 of those. So he looked at it under his microscope and he saw that it has, these spires with little hooks on the end. And so he thought, what a great design that nature has given us. What if we could replicate that, and what could we do with that? And so he created Velcro. A more relevant example for those of us that might be living in the Roaring Fork Valley is skins. As you see this girl here in this picture, she is skinning. She has skins on the bottom of her skis that allow her to move uphill. And we get that inspiration from seals. And in fact, they used to use seal skin, actual seal skin, to create skins for skis. Now that is exploiting the environment. That is not what we're trying to do. We're trying to use the blueprint or the recipe from the environment to create things that would solve our problems. And so now they replicate that seal skin, and they make a man-made product that looks just like it and gives us the ability to move uphill. There are other good examples of biomimicry that we see every day, things like snowshoes, which came from the snowshoe hare. Perhaps when we think about ACES and we think about beavers and beaver dams, maybe that was the inspiration for how we began building dams. This is another very recent technology by a company called Sharklet Technologies, but they began to look at, whales and sharks live in the same ocean. Whales tend to have everything in the world attaching to them, right? They have barnacles and algae and bacteria, and sharks are super sleek skin. They have nothing that attaches to them. So what's the difference between whales and sharks? And sharks have a very unique grid or a pattern on their skin that does not allow anything to attach to it. And so engineers have taken this and replicated it and basically made like a flexible membrane that they're placing in hospitals to prevent bacteria from growing on a hospital surface. And so they've done this in a hospital in California, and it took 3 weeks before bacteria could colonize on that surface. And so they're hoping to advance this product and use it more regularly on things like bathroom doorknobs. Wouldn't that be great if we didn't have any bacteria growing on bathroom doorknobs? The other cool thing about this is because it's not a chemical that's killing the bacteria doesn't have an opportunity to evolve and to build a resistance to this. It simply can't grow on these surfaces. Okay, so mosquito here. One of the inspirations that mosquitoes have given us is that they are able to bite us and we're not able to feel that, right? I mean, you feel it later when it itches, but you don't actually feel that needle going in. And so there are engineers that are looking at what is it about a mosquito's, this is called a proboscis, am I right? Okay. The proboscis is the probe thing. And it's able to enter your skin in a pain-free way. And if we could have a needle that could do that, wouldn't that be amazing? So they're looking at a way to replicate a needle with a mosquito as inspiration. And I think the way it happens, and again, I'm not a biologist, so I'm going to use my terms. They have like these little fangs that come into your skin first and kind of pull your skin apart. And then the probe goes in. And so these little fangs make contact with less surface area than a needle would. And so, the fangs are like serrated as well. And so they're just touching very minimal parts of the skin. And so they pull that apart. And so you can't feel it as well. Okay, so trees are another great inspiration for a process. Trees are able to pull water from the ground and push it all the way up through the tree, out, extending through its limbs and out into its leaves. And it does it without a pump, right? It does it naturally. How is a tree able to do this? And could we do this without using pumps and use that as an inspiration for how to move heat through a building, right? So if we could use solar power to heat water, move that down through the building, circulate that water back up without a pump, wouldn't that be amazing? So there are engineers at Cornell that are looking at developing basically a wallpaper that uses this kind of technology. Okay, so now we're going to talk about how we are using nature as an inspiration here in Aspen and in the Roaring Fork Valley. But first I'm going to teach you a little bit about what I do about stormwater management so we can get a little bit of background before I teach you about how we're using nature. So this is Aspen, obviously, hopefully obviously. And what I love about this picture is if you have ever heard a talk about watersheds or you've ever had watersheds explained to you, this is a perfect image of Aspen's watershed. A watershed is essentially the bathtub of land that all the water that falls into that goes into one spot, into the drain. So you can imagine on an Aspen mountain here, let me find my pointer. All of the water here that falls all into here, all of the snow goes in through the city down to the river, which is basically right in here. So as an engineer and as a stormwater management, this is my job, is to make sure that we can get all of this water that's falling everywhere down into the river safely. And what complicates that job is that we have decided to build a city on top of land that normally would infiltrate all of the water, almost all of the water that falls onto it. And so we've put up hard surfaces, and you'll hear me refer to them throughout the presentation as impervious areas. That simply means that water can't penetrate it. So we have, in order to live the life that we want to live, we have roads, we have buildings, we have homes, we have parking areas. And all of those are made out of materials that water can't penetrate. And so where water used to go into the ground and soak into the ground, it now runs off immediately. And it runs to the lowest point that it can get to, trying to make its way to the river as fast as possible. And so we as engineers have to control that, and it also picks up all of the pollution that's on any of these surfaces and takes that to the river as well. So while I'm controlling the drainage, I'm also trying to think of how we can remove that pollution before it gets to the river, reduce our impact on the river. And that's not a slide proof answer. There we go. All right, so let's think about this for a minute. On your house or on your apartment or wherever it is that you live, water hits the roof, and then where does it go? Gutters, all right? And then it goes to a downspout. And then where does it go? Does anybody know? Right? This is kind of where people get lost. Like, They're like, all right, where does my downspout go? Now, if you own a house and you've had to maintain your gutters and downspouts before, you probably know where your downspout goes. But if you live in like an apartment complex or a condo or the buildings that you go in and out of every day, this is not something that you think about at all. And so it turns out that it goes, all of these hard surfaces basically drain into a network of pipes that are underground. And these pipes all direct water they take it straight to the river. So this is the network of pipes that is under basically the main parts of Aspen. So water in Aspen hits the street, it goes to the gutter on the side of the street, the curb, flows in the gutter line down to an inlet, and then goes into an inlet and goes into a series of underground pipes. And that's how we get water to the river. And then it outfalls into the river in these little points, these that are green right here, these D's, that's where we have outfalls into the river. And so the worst, well, let me explain this slide real quick. Back to what I was saying about how water used to soak into the ground and now it runs off as much as possible. So in undeveloped Aspen, before we built a city here, you might see runoff on the surface about 30 times a year. That means the ground got so saturated during a storm that the water had to start running off on the surface. In developed Aspen, we see runoff 80 times a year. So that's kind of that change of how often the river is seeing something unnatural. And that causes things like it causes the river to swell and fluctuate at times that it wasn't intended to, which can cause weird erosion patterns and things like that. And again, the worst part about all of this is that it carries all of those pollutants. So it carries everything that has ever been dropped onto the street straight to the river. And this happens in every town across the nation. This is not Aspen's problem. Stormwater pollution is the biggest pollution of concern in any water in our nation. It's called non-point source pollution. It means you can't point your finger at a factory or an industry that's piping, or a wastewater treatment plant that's piping directly to the river. We're pointing it at basically we exist in cities and therefore we're discharging pollutants into the river. So some examples of pollutants just in this picture right here. Cigarette butts, anything, any kind of trash, any litter, any debris that's on the ground gets taken into this network of pipes. Oil, you see the oil sheen here, all of that gets taken to the river as well. These large pieces of gravel here, that's what we use to sand our streets. We don't use salt on our streets in Aspen, we use sand. And that's an environmental balance. We don't use salt on our streets because of how environmentally unfriendly it is, but we do use sand, and that sand has a consequence as well. Grinds up into a really fine dust. And so other pollutants that we're talking about are things like fertilizers, bacteria, anybody that doesn't pick up their dog poop, that goes straight to the river. And so those are the pollutants that we're concerned with. The one that is highlighted, or the one that we target as a city, is sediment. Sediment, let me go back before I go into sediment. Let me talk about these real quick. So this is during a rain event, during a storm. That's kind of the color of water that you see going into the gutter. Without knowing anything about it, that doesn't look good, right? We do not want that color of water going into our river. Additionally, this network that we've built to carry water to the river carries anything that happens. So even when it's not melting snow and even when it's not raining, whatever falls onto the street also goes into the system. So this here, this glowing green color, I think that's probably antifreeze leaking from a car up above. And again, all of this goes straight to the river. Even things that are underground can possibly get into this network of pipes and go to the river. So if you guys have been here for very long, you might remember earlier this year, the residences of Little Nell had a problem where they had a sanitary leak into the stormwater system. So basically what that meant was that waste, our poop, to be blunt, was getting washed into this stormwater system and going directly to the river. And if you'll remind me at the end of the presentation, I want to talk about how that was handled later. But yeah, things can be picked up into the stormwater pipes that we don't intend. Okay, so now let's talk about sediment. Sediment is our #1 concern. And this is a hard one for people to understand. Basically, sediment is just disturbed dirt. And dirt is a natural thing, right? It shouldn't cause a problem for the river. But it does because we do it in such an unnatural way. Like, we're disturbing dirt that should not be disturbed. We have a road that goes up our ski mountain. We have dirt driveways. We have construction sites like this one right here. Look at that during a rain event. And so if there aren't proper measures in place, then we lose a ton of dirt into the river. And dirt itself can be a pollutant. It lands in breeding beds for trout and it smothers their eggs. It also can cause the temperature of the river to increase because it's a lighter color than what the natural substrate is. So it can clog pores and things like that. But then also, all of these other pollutants that I've been talking about attach to sediment. And so if we target sediment and try to remove sediment from our stormwater system, then we're also getting a big bang for our buck because we're going to remove all of the other pollutants that are attached to it as well. All right, let's see what's next. This is an example of some studies that were done in the early 2000s. So this is 2003 to 2007. These are just some grab samples that we took of stormwater, the stormwater pipe at Mill Street. So this is, the pipe comes out of the ground very near the Mill Street Bridge into the Roaring Fork River. This is like the color of the discharge in the middle of May. And this blue line here is the national average of cities' discharges of TSS. TSS is total suspended solids. That's another word for sediment, basically, particulates that we're trying to remove. So the national average is about 150. And you can see our discharges in the city of Aspen are up to like 8,000 milligrams per liter. So we're exceeding even dirty cities with how much sediment we're discharging into the river. And so these studies, plus some other studies that were done in the early 2000s, showed that we have a serious problem on the river in Aspen. And so it's difficult for people to understand this because they think of the Roaring Fork River as being this beautiful mountain river, which it is, and a gold medal trout fishery, which it is in certain parts. But in this section here in Aspen, this red section here, and even a little bit further in each direction, is severely impaired. And I like this one study here. There's a lot going on in this graph, and I love that because I'm an engineer, but let me break it down just a little bit for you. This is like Independence Pass is up here. This is Down Valley. This is Aspen Mountain. And so there's the majority of town. So without even knowing much about what this study is showing, you can see that red is bad and that the red part happens in town. So that's basically all you need to know. But what it does show is that it's divided into 3 segments. So these studies looked at the in-stream habitat, so what's happening in the river, the part of the river that's wet. And then it also looked at the riparian areas. And riparian means the stream side, the stream banks on each side of the river. And so those are an important part of the health of a river, very important part of the health of the river. And so they looked at the riparian areas as well. And you can see here in the city, we did terribly. And, oh, it also did a bug count. So macroinvertebrate population, that's a big word for bugs. But they're indicators of the health of a river because they affect the entire chain, eco chain of the river. And so we failed in all regards in this study, and we did in a lot of other studies. And the citizens of Aspen got together and said, this is embarrassing and an atrocity. We cannot pride ourselves on being the environmental city that we are and have this problem with our river. And so they got together with city staff, and that's how the stormwater program was founded. It was a grassroots effort to build this program. And in 2007, they voted to tax themselves to pay for the program, and with overwhelming approval. And so this program began in 2008. That's when I was hired. And it was to tackle this problem here. We do not want to have this problem anymore. Do something about it. And here's all the money that you might need to pay for it, which is amazing. There are not many cities in the nation that give this kind of attention to a problem like this. And so I'm very lucky to live here. You guys are very lucky to live here as well. And thank you for supporting the program if you pay taxes. Okay. Reasons that they found that this was probably an unhealthy river. What's causing this problem? And these, again, are easy to point out. You remember where I pointed to where all of our discharge points are into the river from that network of pipes? They all happen right here, basically, all happen in that red section. So our urban pollutants that are falling on our streets everywhere, on our buildings, are getting discharged into the river. So stormwater outfalls, stormwater discharges, that's a #1 concern. Riparian areas, again, these are the stream banks that I was telling you about. Well, obviously, in the city of Aspen, people have built right up against the river, and they do it because they love the river. They're not trying to damage the river, right? Most people that live on the river really love rivers. They want to see it. However, that's very damaging to a river. It needs its riparian area to stay healthy. And this lack of water, this one I'm not going to talk very much about tonight, but it's a really interesting one that I want you to go home with. This river has significant diversions off of it. And so there is a trans-mountain diversion that takes water from the headwaters of the Roaring Fork River up at Independence Pass through the Continental Divide, through the mountains to deliver water on the Front Range. There's also a significant irrigation ditch that comes off of the river just below the North Star Nature Preserve. And those two diversions can cause this river to almost run dry. Certainly during drought years, it almost runs dry. And just gut check, rivers running dry aren't great for what we expect our rivers to do. But it also causes these problems for these macroinvertebrate populations, for bug populations. It tends to run dry during the time of year when we are not getting rain, which is in like late August, September, October, which is also when the river is naturally very low. We've had our snowmelt in May and June where the river swells and everybody goes rafting and it's wonderful. And then the river level really drops. And so that's when those transbasin diversions are pulling as much as they possibly can because they need water as well during that time. And so that's when the river level is its lowest and temperatures are at their highest. And so that water, again, heats up and it doesn't support a good macroinvertebrate population during that time. Okay, so I started in the program in 2008. And so in the last 8 years, those three problems right there, I've been tackling stormwater outfalls the most. So that's where we focused our attention as a stormwater program. In the next few years, we're going to be focusing more on riparian areas and that lack of water. But today we're going to talk about how do we improve our discharges into the river and our stormwater outfalls. Okay, now we're back to biomimicry. Okay, see how it cycles around. All right. Okay, so how do we do this? How do we handle our stormwater discharges? And there are 3 ways that we do this as the City of Aspen, and they're pretty simple ways. One is we decrease the runoff. All right, we don't have to remove pollutants from water when there is no water to remove it from, right? So we try to encourage developments and redevelopments and us as the city as a whole to just not put in the hard surface, okay? Do everything you can to keep those hard surfaces minimized. Like instead of building a ranch house that reaches out, as far as possible, why don't you build 2 or 3 stories, and you decrease that footprint, therefore decreasing that runoff. Increasing infiltration. So if you are gonna have runoff, put it into the ground as soon as possible. Infiltrate it into the soil as soon as possible. Don't let it get into a street system where it then gets into our network of pipes. So introduce it into green space as quickly as you can. And then whatever's left over, we're gonna treat it, which means we're gonna remove the pollutants from it as naturally as possible. All right, so this is Spring Cafe. If you haven't eaten there, it's awesome, you should go. And it's a new building, and this building basically, in order to meet our requirements and to abide by these guidelines that we have given it, put in a green roof. And green roofs are genius. They've been used for centuries. But they basically, they make the building, they mask the building. The river does not know this building is here, okay, because it doesn't generate any runoff. It has a green roof on it. Water falls on that roof, goes into the ground just like it would if that green space there was located right on the ground. So basically that building has been masked. They don't have to do anything else. So this is the best bang for your buck, is to do green roofs. We totally encourage it. It also makes for a beautiful roof. If you're in your penthouse looking out at the rest of Aspen, you can see nice green space instead of mechanical systems. Here's a beautiful example of a green roof right here on this building or this house in Castle Creek Valley. I love it. Here's some other examples of ways to just take small spaces and decrease the runoff from those small spaces. This is at the Museum of Contemporary Art in Denver, where they have just been really creative with their use of planters. This is another way to decrease impervious area and to reduce your runoff and increase infiltration. These are grass pavers, so if there's areas that you don't drive on very often or you don't park in very often, you can obviously plant grass and just use the minimal hard surface necessary to support a vehicle. These are other examples of modular pavers that look a little more like a traditional driveway, but they have huge joints in the cracks there. And so those joints are filled with gravel and water can infiltrate straight down into those joints. And so instead of running off of this driveway, it just soaks into all of those joints. The other cool thing about systems like these is that they're built with basically reservoirs underneath. So they have a huge gravel bed underneath. So in addition to the water that's falling on them, you can send this water that's falling on this roof into them as well. So they have a chamber. So that way you're reducing your impervious area, decreasing runoff, increasing infiltration, all at the same time. Here's another beautiful example of a green roof in Steamboat. So you can see water would shed off of this roof into this green roof. So you can use those for that same reason, to increase infiltration. And these are water treatment. These remove any pollutants as well, because that's what we're talking about, is just sending it into the earth. This is an example of a small little rain garden. You can see their downspout right there. Discharges right into this little landscaped area. So we require this of development and redevelopment in Aspen, but there's not, development and redevelopment in Aspen can't handle all of the problems. They're just required to handle the problem on their own site. And the City of Aspen deals with the rest. So all of the streets and all of the buildings that have been here forever that are not redeveloping, that's what we're having to treat. We also encourage people to be creative. Wherever you're going to have plant life anyway, why not send stormwater to it? And to be artistic. Water is one of the most valuable resources that we will ever have. Why not celebrate it, showcase it, be proud when we see it? And so trying to think of ways that showcase water a little better. This happens in Portland. If you visit Portland, now that you've heard this talk, you'll look everywhere and see these examples of the way that they celebrate water. And so we're trying to encourage developments to do things more like this. I love this example. Like, this building wanted to practice these things that I'm preaching here. And so they needed to send water over to this green area, but they had this stuff in the way and this concrete down here in the way, and they couldn't do it. And so they got creative of like, all right, instead of doing something ugly to get it all the way over to here, what can we do that's cool? And so I think this is a great solution to a difficult problem. Okay, so once development and redevelopment has done what they can do, the city gets to do the rest. And this is where you really get to visualize how we're using nature as our inspiration. And so you'll see this heading that I have up here, green versus gray. And that's what I want you to think about in these next few slides. Typical stormwater management, typical engineering practices, you take that water, get it under the ground as quickly as possible so that nobody has to see it, and you have to use concrete pipes to make that happen. And at times you have to pump it because we can't always get everything downhill. And so we are trying to avoid that. That's an unsustainable solution. The life of concrete is pretty long, but concrete's not a renewable resource. And so we are trying to keep everything green as possible, and using things that you would find in this valley to create that, and making it look like something you would see naturally. And the reason that we do this is not just an aesthetic. Let's go to the part where nature does this best, right? We're infiltrating into the ground, and so any pollutants that are carried in stormwater that actually go into the ground go through a matrix of soil. And so we're talking about like just close-knit web that water has to go through. So there's a mechanical process where it's physically being removed because it can't fit through all of those holes. So those particulates that I'm talking about physically can't fit through. They're stuck. But then there's also those metals and bacteria and excess nitrogen and phosphorus and things like that. And so those change as they're introduced into the soil, and over time, the chemical processes begin to change those into things that plants can use. And then the plants take them up and use them for food and use them as growth. And so that, those pollutants actually get transformed into something that is useful for plants. And so that's for the water that soaks into the ground. But then we still have runoff. We still have water that's going to move across the top of the ground. And that we send through these grassy systems like this. When water the level gets so high that it overtops into these banks here, then it also has to move through that web. It moves through a web of grasses, right? Grasses and landscaping and whatever we can put in its way. So that, again, is a physical barrier, removes some of those pollutants, but it also slows that water down so much that the heavy particulates that are in it have to settle out, and they settle down into that dirt, and then they infiltrate down into that soil, and they go through that process again. So that's how we're using nature as an inspiration. So take this street here. Instead of a typical curb and gutter with an inlet that takes it into a pipe underground, this street, whatever falls on this street, whatever pollutants like oil, gas, whatever's falling, metals that might fall here, they just run off into this ditch over here, and they soak into the ground, or they overtop it and they start making their way down. So it's so simple, right? Why do we have to complicate things? So these are just other fine examples of swales that you may not have ever noticed before. This is Cemetery Lane. We use that for our drainage on Cemetery Lane. These are examples where we're using the city's right-of-way to accomplish this as well. There's lots of reasons that we might bulb out the curb and take away parking. Part of that is it's a more pedestrian-friendly crossing point. You give the pedestrian less interaction with vehicles this way. But it also, check out that grate right there, that little cut. All of the stormwater coming down this street goes into that cut and then fills in this area right here. So this is an example at the S-curves. If you're paying attention at the S-curves where they have those bollards that are blocking off like Hallam and Bleecker, I think, maybe Hallam and Bleecker. We're taking stormwater there into these little tiny ditches. And so it doesn't have to be a large scale system that we're putting this into. We're doing it in pockets wherever we can. This is a great example of how private development handled their stormwater in their city's right-of-way. So obviously this is the art museum, but these that you may not have noticed down here, these are bioretention areas, bioretention cells, rain gardens. We use all those words interchangeably. Well, the runoff in this street come into these inlets here, and they get into this planted mid area here, and all of those pollutants get filtered out. And so this was a partnership between the art museum and the City of Aspen because we allowed them to do this within the right-of-way, which is public space. We don't usually allow developments to use public space. But we allowed them to do that because they're doing a public benefit. They're treating the city's runoff, the street's runoff, and their own runoff in these areas. These are also all pervious pavers. There's just a few in there that you'll see if you walk over them. There's a few that are jointed with concrete. I believe that was for a pedestrian or an ADA reason. But the rest of them, you can see the open joints and the water infiltrates straight down into those. The other cool story right here is that in April of last year, we had a truck pop a hydraulic line on this street, and they lost about 5 gallons of hydraulic fluid into the street. And that normally would have been picked up into an inlet and taken straight to the river. No chance of stopping it. Instead, it was picked up in this inlet here and taken into this system right here. Now that aggravated the art museum because they had to replace all of that. It basically killed all of that vegetation, but it protected the river. It did its job. So that was huge for us. It was a great example of how these things really do work and are worth every penny that we spend on them. And so then we think about it on a bigger scale. I was showing you kind of microscopic pocket wetlands and things like that. Let's think about how nature really does this. And looking at this river, this is the Roaring Fork River. This is riparian area. This is what we're aiming for. This lush, treed vegetation. Pollutants don't have a chance of getting through that, right? They're going to get taken out by that. So that's what we're trying to replicate in large scale areas when we do our larger projects. We can't always restore riparian areas to look like this. This takes many years to develop. This is an example of what we don't want to do. This is off the Cooper Street Bridge. That's a condo right there. That's not a good riparian area. That's not the way nature planned it. This is a good example of a sandbar over here on the side. So I'll talk a little bit about how we've replicated a sandbar. This is a great picture of my staff doing their job in the river. All right, this is an example of the river in North Star, and these are wetlands growth all around here. And so now we're going to play a little game. In the next few pictures, I want you to tell me if you think they're natural wetlands or man-made wetlands. All right? Natural or man-made? Jim, you can't play. That one's man-made. That's Jenny Adair. That's one of our facilities that's located right outside of this property, or actually on this property. It's a joint project between the city and ACES. And I'll talk a lot about how that facility functions. Man-made or natural? Natural. Dang, y'all are good. Man-made or natural? Oh, this is too easy for you guys. Okay, you're getting it right. This is Rio Grande Park. This is another project I'm going to talk to you guys about. Natural or man-made? I know, this one's hard, right? I think this is man-made. I didn't take this picture. I didn't take a lot of these pictures. If any of you took these pictures, please let me know so I can credit you. And also, I thank you for taking pictures of our work in Aspen and posting them on the internet so that I can use them in presentations. Okay, I don't know about this one. This is a picture from the Aspen Times, and I can't tell where this was taken. I think it was taken in Rio Grande Park because of the boulders. I think that's what gives it away for me. Natural or man-made? This one's man-made. This is Jenny Adair. So this is right, you have to drive past this to get into here, or to get into the parking here. And this is Jenny Adair during a storm event. So you can see how dirty that water is going through there. And then I'll have an image of how clean the water is when it comes out. But let's talk about the Jenny Adair facilities. So like I said at the beginning, there's two ways that we engineer. One is to control the environment, one is to mimic it. And we have to do both in order to keep the standard of living that everyone has in this community and across the nation. But this is the very controlled part of these facilities. It happens in these vaults upstream. And so before we discharge into the wetlands, we need these vaults to do the really heavy lifting. And I'm going to show you pictures of why. But these vaults are 15 feet deep. They're 15 feet wide. And they have like basically these baffles. These are called baffles, but they're concrete walls throughout it. And they create a maze within this vault that's underground. And this maze makes the water go through, it's like goes back and forth and back and forth. And so the purpose of that is to really slow that water down, all right, and try to drop out as much of the heavy particulates as we can. And also it has a trash rack. So we're removing the floatables that are on the water and a lot of the debris that comes in. And then it has an oil chamber to remove some of the oil before it gets into the wetlands. And we do all of that because these wetlands and these biofiltration areas that we're doing, I mean, we're using park space to do it, and so there's an aesthetic component to it. We do not want these to look horrible for people. We want people to not know that they're there, basically. And so there's that, but there's also, it's a maintenance nightmare. Like, look at this. There's no way that we could send our staff out to clean up popcorn peanuts out of the wetlands, out of the Jenny Adair wetlands. And so this does a lot of that heavy lifting. This is what I clean these things 3 times a year with vac trucks, and we remove dump truck loads of material every time we do it. Yeah, 3 times a year. Yeah, we clean these vaults 3 times a year. And this pipe is 3 feet above the ground, above the bottom of the vault. So that's 3 feet deep in that kind of muck right there. Every time we clean it. Yeah. And so I think we've removed 24 dump truck loads of this material since these things have been functioning. And that's just in the vaults. And so they're just doing the heavy lifting. The wetlands are doing the polishing, and they're doing a job that we can't do mechanically. We can't recreate this in an engineering world yet. Wetlands are able to polish it to a degree that we can't. So after it moves through the vaults, then it comes out of these pipes here. There's 2 that come into this is again the Jenny Adair wetlands. There's 2 that come into the wetlands. Now this is a picture taken probably a year after these wetlands were planted. I can't take a picture like this anymore during growing season because you can't see any water at all. You cannot see these ponds. You can't see through this area right here. So I'm using these older pictures, but know that it looks really different than that right now. So the water comes in. This is called a forebay. It settles out right here. This is again just a mechanism to really, really slow the water down. And then it just spreads it out, and it moves through all of this vegetation until it gets to a point around here. Let's see if I have a picture of that. Oh, this is just an example of this is one of Jim's pictures, and I think this was probably 3 years ago. Like this isn't even and so you can't see that pipe from where I'm standing. Like if you stood out there today, you wouldn't be able to see that pipe. Okay, so there it is in the background, and then it moves through all of this system here, goes over this log into another pond. And the reason I wanted to include this picture is this is a tree here. So typically in a typical engineering solution to make this happen, to make this water move at the speed that it should move in order to drop out the pollutants that we need it to drop out, we would build a concrete retaining wall with an orifice, which is a fancy word for a tiny little hole that controls the speed that we let the water out. Or we would put like a notch in the top of the concrete wall. But because we're trying to do this as naturally as possible, as sustainably as possible, we use as much natural material as we can to create these exact same things. So this is a log. It's at a perfect elevation to control this water, and it only lets the water flow over at a certain rate. So people are like, well, you're gonna have to replace the log, right? Like the log is gonna decay. And we're like, yeah, we're gonna have to replace the log. We can get another log, 50 of them, anytime we want them. You know, like, yes, we're gonna get another log, we're gonna put it in there, we're gonna survey it, make sure it got to the right point, and that's it. We're not gonna go order another piece of concrete to be made specifically to fit this solution. So we're happy to do that. This is where the wetlands discharge into the river. Okay, so look at that. That looks the same color, right? We love seeing this. These are some photos from Jim. I asked him to send me some pictures of the habitat that we created. So in, you know, some of the side benefits of this is like obviously we're doing great things for water pollution control and for the health of the river, but also we're creating a habitat for the animals that should be living in these areas. There's a blue heron standing in the outfall that I took just this year. And then I love this one Jim sent. There's a little bear taking a bath in this pond. It's incredible. All right, this is another good example. This is Rio Grande Park, and this is like the pride of the stormwater program so far. This was when that citizens group got together and thought there should be something done to improve the health of the river. This was their highlight project. This is the highest priority that they had. And we completed this in 2015, began construction in 2012. And the reason that this is such a great project is because 30% of the city's runoff goes through this system. So 1/3 of the city gets treated through this system, which is great. We have 2 points of entry. One is down here near the recycle center, and one is right here on Mill Street. And again, we have vaults, just like those ones that I showed you pictures of, that do that heavy lifting, and those get cleaned 3 times a year as well. So there's a vault here in the recycle center and a vault here in the sidewalk. And the water comes in here. Once it leaves that vault, it comes into a 4-bay area here. Again, just a way to really slow that water down and to spread it out the way we want it to spread out. Then we used 2 different systems here because we kind of wanted to demonstrate what we're doing. So we used wetlands on this side of the park. And then on this side where you see these cottonwoods, it's basically a sandbar. That's what I was talking about earlier. We wanted to protect these cottonwoods, and so we couldn't do a lot of work in the area. So we kind of added some sandy mix to it. And basically when the water moves through this area, it surcharges over the sand and infiltrates in. And so we're going to monitor and see where we get cleaner water. Do we get it? Is it cleaner after it's gone through the wetlands, or is it cleaner after it's gone through the sandbar? And so I should have that data in the next few years. Basically what we've seen so far is that they do equally great jobs. No discernible difference in the data. And then there's a nice ponding area here, a pond here, a pond here, a pond here, before it discharges into the river. And the purpose of those ponds is to just slow that water down as much as possible and allow anything that's floating in it to settle out, allow those particulates to settle out. On this western side, it goes through a biofiltration swale. So essentially the water's moving through like looks like a little stream, and then it goes into this kind of more pondy wetland looking area here. But if you go and just stand right here on the edge and look over into this, you'll begin to see, like on days when it's not raining, you'll see little pockets of wetlands. And I mean little pockets of wetlands. They're like this big, but they look just like a tiny wetland. And so when the water comes in during a storm event and begins to surge and the level comes up, it starts to flood those wetlands, and it either moves through them or infiltrates into them. So got several pictures that I want to show you guys of what this looks like. This is that 4-bay area, and the water splits and goes in these directions. Again, the way that we make the water go where we want it to go when we want it to go there is through really natural materials. So that's a super, super, super flat rock. And it's placed at a very distinct level. And so when the water rises during a storm, it begins to overtop that level right there and go into this wetland. These are some pictures of some of the wetlands. And again, these were taken just a few years after this wetland was finished in 2013. And so these were taken probably in 2014 or 2015. And this is that wetland on this side. This is the main channel of water. So this is kind of always running a base flow through it. And then the sandbar is back there where those cottonwoods are. So pay attention to where those cottonwoods are. And then look at that. So this was taken last year. So that's how much it's grown in just a few years. So like I said, you can barely see the water now. And then also look here. Look at all these pollinators. Look at all these bees, butterflies. So we're creating a nice habitat there. This system looks very different than Jenny Adair. The Jenny Adair system is a much more natural looking wetland. This gets a lot more visitors and a lot more park use, and so our Parks Department wanted to develop something that looked a little bit more inviting for tourists. There's people walking through. More examples. This is Theater Aspen. We have these block systems here, so we want to really encourage people to move down to the water. You know, there's lots of studies that prove that water improves people's quality of life. It improves their attitude, their happiness. So we want to work with our Parks Department to pull people towards water. Again, celebrating water. This is a magnificent thing that we have. We don't want it hidden underground in pipes. So in addition to all of these natural treatments that we're doing, we get all of these side benefits as well. People learn about water once they figure out what all this is here and begin asking questions. They begin to learn in this way, in ways that they would never learn if this was underground in a pipe. This is, okay, so this is the western side. This is that, you know, that stream that I was talking about that has bioswale or biofiltration on the sides. And what I wanted to come back to was that residence is a little nail issue. And so while we have designed all of these facilities to remove pollutants that attach to sediment and remove sediment, we had E. coli coming through the system, a heavy bacteria, lots of it. And so unfortunately we had to close this off, this waterway off, so that we couldn't, you know, allow our public to engage with it during this time. But the cool thing is that it did its job, and the water that was entering the river had very little E. coli in it. And so again, we protected the river in that way, in kind of an unexpected way. We didn't design this to remove E. coli. This is the outfall from Rio Grande Park into the river. And again, it's hard to see how clean this water is. So we have this image here to kind of show we sample these facilities regularly to see how efficient and how effective they are. This is what water looks like going into these facilities, and this is what it looks like coming out. So these are designed to remove 90 to 98% of the pollutants that are coming into them, and they very regularly test at about an average of 96% removal. We also test the river upstream of North Star to see what's just naturally in the river, and the TSS, that thing that we monitor, total suspended solids, is about 4 milligrams per liter in the river, and we are discharging at 4 milligrams per liter. So we're mimicking what the river should see. With these wetlands. I just wanted to talk here about more of those side benefits. I think I've mentioned most of them already. This image makes me think, like, people have their weddings here, you know, at a stormwater facility. It blows people's minds, you know, like, they have no idea that they're at a stormwater facility. You know, they think they're at a beautiful park, but they have weddings here. It's amazing to me. And the other cool thing that I wanted to tell you about is that this is scalable, okay? You could do this wherever you wanted to. You could do this at your own house. Let's go to this image first, and then we'll come back to that one. But yeah, you just take your downspout, put in a pretty rain chain if you want to, and put it into a gravelly area. Just make sure it's not going straight onto your driveway and into the city streets. And also don't, you know, flood your neighbor. Don't point it at anyone, okay? and don't saturate your foundation. Okay, that's all my caveats, okay. But anyway, this is an example of a rain garden that somebody put into their yard. You know, just using your landscaping instead of mounding up your landscaping, why not just depress it so that water can go to there and and those pollutants can be filtered out. You can also use it to grow your vegetables. Change your downspout configuration to something like this. Plant vegetables in it. Okay, let's go back to the rain barrel. A very cool story is that rain barrels are finally approved in Colorado, and you can have one at your house. So rather than letting that water soak into the ground during a storm event when you don't really need it for your irrigation because you're getting the storm on anything that you're trying to irrigate, you can store it in a barrel. Just all you got to do is pop a little hole in your downspout, put it into a barrel, and then you can use that to water your lawn a week later when it really needs the water. So to bring it all back, what I want you to do is just begin to look at the things around you and begin to ask, you know, how hard is nature working for me? Exactly what is nature doing for me? And what ways can I look to nature to help solve my own problems or to solve problems of humanity or solve problems around me? This is a wonderful quote. It says, "Let nature be your teacher." So that's all I have tonight. I'm going to take questions, but we have to do it into a microphone. So wait till the microphone gets to you and then speak clearly into the microphone. So anybody have questions? Go ahead and raise your hand. All right, right here.
Thank you for your talk. Really appreciated it. A buddy of mine works in the Carson National Forest and does a lot of this locally sampled materials to control erosion. He's not dealing with pollution so much as preventing erosion in the first place. And he kind of speaks to all this stuff that you said. That it's easy to get, it's cheaper to get. But in the end, this is a lot of extra work for local governments and local engineering departments. And there are a lot of towns, speaking more to the scalable side of this approach, there are a lot of towns that have bigger populations, less space, and probably less agreeable taxpayers with fewer funds.
Yeah.
And so all those considered, do you see this being something that we could spread across the country as a means of addressing stormwater pollution?
Absolutely. So just to talk about the economics of it for a second, it is not more expensive to do it this way. It is much cheaper to run water on top of the surface through a swale, especially if it's a naturally occurring swale, than it is to buy concrete pipe, excavate, build a construction project, close a street for 2 months, and put that pipe in. There are lots of studies out there that show how green infrastructure is much cheaper to construct, and then it's also much cheaper to maintain. So I can see if I have a problem in a swale, right? My staff can just go out there and inspect it. If we have a problem in a pipe, we have to rent video equipment and hire someone who has confined space entry safety certifications, and they go down into the hole and they send this little, remote controlled video camera, and then you have to pull that back out. And then if you do have a problem, you have to figure out how to remove that problem, which requires excavation, replacement of pipe, closing a road again. So it is much cheaper to do it in this more simple way. The problem is that, this balance of what you're willing to give up. And so let's think about in Aspen, we have very, very, very expensive land, and this requires land. And also we have, very small properties where people want to maximize their building on their property. And so when I have requirements for them to do these things, this is where it comes into play. And so it often gets pushed underground, and they have the money to pump it back up. All right. So rather than solving it the cheaper way, they prefer to go the more expensive route. And so that's kind of a battle that I do at work on a daily basis. But absolutely, it's a cheaper solution to do it as green as possible. And as far as, bigger cities being able to do this and cities without land, yes, we are kind of in a unique situation because we have such an agreeable parks department. We own land as a city where we're able to marry these two things. I think that those examples that I used of just the little pocket things in the right of way, those can be done in any city that's willing to give up a parking space, just one parking space to accomplish this, And there are lots of advances in the industry where you can, do it kind of beneath the ground, but in a greener way. So there's things like silvacells where you're growing trees in it, but you could also send stormwater to it. So it just takes a little bit of breaking outside of the box, thinking outside of the box, being a little more creative and a little more, willing to risk that traditional, comfortable way of engineering. Yeah, you're welcome. Any more questions? You got one right up here. Wait for the microphone. Thank you.
So, April, I know you don't work with water or wastewater, but do you see how you're treating gray water with your stormwater system? Do you see that being applicable to the aging water infrastructure in the United States?
Yeah, I don't think that, that's anything close for me to be doing. I think that's more something that our water department might be doing. And, I love the idea of using gray water. And so, for anybody not familiar with that term, gray water is, we have clean water that comes into our house that has been treated, and we have black water that goes out, and I think it's obvious what's in the black water. And then we have gray water, which is kind of what's in the in-between. So like that might be what is coming out of your sink when you're brushing your teeth or something like that. And absolutely, I think that gray water has its place, and I think that we will see a push to that, certainly in places like Colorado where water is such a scarce resource for us, and we're looking for every option that we can to make the most out of water. But I hope that the City of Aspen is going to begin to think about, I think some of the approvals that we needed from the legislation just recently happened in Colorado legislation to allow us to begin using gray water. And I know Denver is taking some steps to begin allowing the reuse of gray water. And so I think that we'll be looking to them for an example. But I think that Aspen should be pushing the envelope on that. Yeah. Jim?
Thanks, April, for a great talk. I wonder about the metals and pollutants that make it through the baffle boxes and get, those get pumped out, and I'm sure they get taken to someplace. And I don't want to know about, I guess. But the things that go into the wetlands are taken up by the plants. They don't go away. I'm sure that oil that the bacteria ate, the oil, maybe it does go away. I missed something. But how do you handle that? How many years in the future do you have to deal with that? And is that after you're kind of off your post?
No, I don't think so. I think we'll probably replace those wetlands. Our guidance says that we probably need to replace the Jenny Adair wetlands something like once every 30 years, which replace means basically we need to go in and muck out everything that has settled on top of them, which also means extricating all of the plant life and replanting them. And that's something that we have planned for. And like I said, there is a chemical change in those metals and those nutrients when they're pushed through the soil, and then the soil begins to break them down and change that chemistry. So the ones that actually make it through the ground, I'm not as worried about as just the ones that begin to muck up on the top. Yeah, and so we'll go in and remove all of that, like I said, about once every 30 years. And I think that, it's going to be helpful for us to begin testing the what's settling onto the bottom of those wetlands, just to be sure that our plans and our thoughts about how that might work are true. Yeah. Any other questions?
First of all, I'd really like to compliment everybody involved in that Rio Grande project. That just came off so terrific. I've had visiting friends I've taken there that had no idea that it was a wetlands. They just think it's the coolest park in town.
Thank you. That's what we want. We kind of want people to really not know it's there, but then we want to reveal that to them, Yeah.
And I live not far from here and been walking over the Mill Street Bridge for years and noticed that, especially in the late summer, after a thunderstorm, that plume that goes into the Clear River, is that a solvable problem? I haven't really paid attention to whether it's as bad as the first few years that I lived here, and it was, glaringly ugly on a August afternoon when just this ugly stripe of crap was going into the river.
And this is from the Mill Street street bridge, the vehicle bridge?
Yeah.
Okay.
And just on the other side of the river.
The upstream side?
Yeah, and it looks like Red Mountain Road and Gibson just formed this catchment that gets washed right into that storm sewer, and then it's only 25 feet to the river. You got 25 feet to do something with it.
Right.
What do you do with a problem like that?
Yeah, no, that's a great question. And so, we've done the Rio Grande Park. Like I said, that was a high priority project for us because of how much of the city that it treats. But we're not stopping there. I have plans to do these kinds of facilities at every one of the city's major outfalls. And that is a major outfall that you're talking about, and it is on my capital plan for sometime in the next 10 years. So we've begun thinking about what we can do in that intersection of Gibson and Mill and Red Mountain Road and the old Aspen Art Museum parking area. We own a lot of land there again. Which is really fortunate for the city that we are to own this land right here where these outfalls are coming together. And so we have plans we're kind of waiting to see what's going to happen at the old Aspen Art Museum and what kind of programming it may have, because there's going to be possibly a redesign of that intersection and how that's not the safest intersection. I don't know if you guys have tried anything there. So one of the great things about the stormwater program is that we're in the engineering department, and so we are able to look a little more holistically at engineering designs. So rather than go in and do a stormwater project and then 2 years later do a pedestrian project and then 2 years later do a transportation project, we're kind of looking at that area more holistically. But we have a lot of right-of-way in that area, even on the other side, away from the Aspen Art Museum. And so that outfall is on my list of something that I'd like to do in the next 5 to 10 years. Yeah, thank you.
Is that just like a condo for mosquitoes?
That's a good question, and I think most of them have lids. That was probably a really bad example. Yeah, most of them have lids. We don't have a mosquito problem in Aspen, which is amazing. It's a really funny story. When I first started working here, I began to ask that same question. As a stormwater professional, we always get attacked of like, you're breeding mosquitoes in your wetland, you know? And so I began talking with him about what's the concern of mosquitoes in the area? And he's like, we went to a conference once where people were comparing all of their monitoring and how many mosquitoes they catch in a single night. And like, most cities catch like 5,000. And he's like, we caught 5 in all of the city of Aspen. So we don't really have a mosquito problem here in Aspen, but if you live down valley, it's certainly something that you could be concerned with. And I think most rain barrels come with a lid.
They can't afford the laser either.
Yeah, mosquitoes cannot afford the land prices here. Yeah, there's a question over there.
I think we're just going to take one more question.
Okay, great.
I don't know if you can speak to what Pitkin County is doing, but I'm wondering if they are doing something comparable, in particular about groundwater recharge with the conversion of all the alfalfa fields to development and recharge of the aquifer, and what Pitkin County is thinking about that.
Yeah, so I'm so glad you asked that question because I completely forgot one of my points of my talk. Groundwater recharge. Okay, so we talked about the fact that water used to soak into the ground. Now it runs off as quickly as possible. One of the great things about doing green infrastructure is that you get water back into the ground as quickly as possible, which is where it needs to be, because it takes it about 2 months to move through the ground in Aspen back to the river. And so if it's happening in July when we get a lot of our thunderstorms and you can get it into the ground, then it comes back into the river in September, which is when we have our lowest levels in the river. And so there's that extra benefit of the groundwater recharge, which is so critical. So I'm glad you brought that up. As far as what Pitkin County is doing, they don't have a substantial stormwater program. They don't need one as badly because they're not in an urban area where you have a lot of connected impervious area and you have a pipe system that's handling that. They have a lot of properties that have tons of land, and so their downspouts are probably going somewhere on their property. And anything, they don't introduce as many pollutants as we do. Their roadways are of concern, but they don't have like a street connection and a grid like I showed of the city of Aspen's, where it's just a lot of hard surface, all connected and all discharging into the river in just a few points. And so they don't have as great a need for a stormwater program, but I don't know if they have any particular guidelines or policies about what a property should do when it takes what was pervious area and puts in its new house or home or driveway. I don't think they have any requirements for water quality concerns. They obviously handle stormwater runoff in that you can't flood a neighbor, so you can't begin directing things at people. They have a stronger river protection ordinance than we do. You can't build within 100 feet of the river. In the city of Aspen, it's not as restrictive, but we're going to work on that. All right, thank you guys so much. It was really great talking to you.